Hello students, welcome back to the fifth video of this playlist. In this video, we will be solving question number 5 from the most recent past paper of Further Pure Mathematics, which is the May 2024 F1 paper. So let's get started with question number 5 of this paper. Okay. So the question number 5, it says the equation 5x squared negative 4x plus 2 equals to 0 has roots 1 over p and 1 over q. Part A is asking here without solving the equation. Part 1, it is asking to show that pq equals to 5 over 2, and part 2, it is asking to determine the value of p plus q. Okay. So for part A, the equation given, we should make it in the form of x squared plus bx plus c. Basically b over a plus c over a in this form equals to 0. Why we have to convert in this form? Okay, I'll tell you soon. Okay, let's have a look. X squared, so that would become x squared negative 4 over 5x plus 2 over 5 equals to 0. Okay, so we know that for a quadratic expression in the form x squared plus b over ax plus c over a equals to 0, b over a, the negative of b over a, it is basically the sum of roots. Okay, and c over a, it is equals product of roots. That's why we have to represent it in this form. Okay, so sum of roots, the roots of this equation is 1 over p and 1 over q. So sum of roots here, it is equals to 4 over 5, the negative of the coefficient of x, right? So we can write 1 over p plus 1 over q. This is equals to 4 over 5. Okay. So 1 over p plus 1 over q equals to 4 over 5. So let's take LCM, that is pq. So pq is the LCM, so q plus p. So q plus p equals to 4 over 5. Okay. Again, we know that product of roots, it is equals to the constant, that is 2 over 5. Okay, so we can write 1 over p times 1 over q, that is 1 over pq, it is equals to 2 over 5. So in part 1 they have asked to show the value of pq, so p times q, just reverse the fraction, you will get 5 over 2. Showed it's for part 1. Okay, now use this value of pq to get the value for p plus q, that is asked in part 2. Okay, to be determined. So p plus q would be 4 over 5 times pq. So pq is 5 over 2. So that would give you 4 over 2. It is 2. 5 cancels out. So it is just 2. That's the answer for part 2 of A from question number 5. And that's all about part A. Fine. Okay, next is part B. Here the question is asking, hence without finding the values of p and q, determine a quadratic equation with roots p over p squared plus 1 and q over q squared plus 1, giving your answer in the form ax squared plus bx plus c equals to 0, where a, b and c are integers. Okay, so we need to find out an equation, a quadratic equation, which have roots p over p squared plus 1 and q over q squared plus 1. So we will use this concept. Okay, the sum of roots is negative b over a and the product of roots is c over a. So at first figure out the sum of roots. Okay, let's figure out the sum of roots. For part B, sum of roots at first. Sum of roots, it is p over p squared plus 1. P over p squared plus 1 plus q over q squared plus 1. Okay. Now take LCM. So in the LCM, you will get p squared plus 1 times q squared plus 1. Okay. And in the numerator, p squared plus 1, p squared plus 1 cancels out. So p times q squared plus 1 plus q times q squared plus 1, q squared plus 1 cancels out. You will get p squared plus 1. Okay. Now expand the numerator and the denominator. So you will get p squared q squared plus p squared plus q squared, p squared q squared plus p squared plus q squared plus 1. Okay. And in the numerator, you will have pq squared plus p plus p squared q plus q. Okay. Now let's rearrange this equation, this fraction. So take pq squared and p square q together. So p squared q plus pq squared plus p plus q. Okay. Over, in the denominator, we have to rearrange it. So what we can do is that p squared q squared can be written as pq whole squared and p squared plus q squared. Okay. So p squared plus q squared should be substituted with p plus q whole squared. Okay. How can we substitute it? Let me show you. P squared q squared, it can be combined. It can be kept as it is, pq whole squared plus 1, and just in place of p squared plus q squared, only for p squared plus q squared we will do some works. Okay. So we know that p plus q whole squared, it is p squared plus 2pq plus q squared. Okay. So if you take p squared plus q squared together, so p squared plus q squared, then take 2pq on the left side, you will get p plus q whole squared negative twice of pq. That's what we will do here. Okay. So in place of p squared plus q squared, we can put p plus q whole squared minus twice of pq. Okay. Now just put the values. Okay. Why is it necessary to represent the fraction that we have derived in terms of pq? We are basically we have just represented in terms of pq and p plus q. Why? Because we know the value for pq and p plus q only. That's why we have to do so. Okay. Now just put the values. Okay. Before that, let me show you how can we simplify it further. Pq times p plus q, and there it is just p plus q, p plus q. Okay. We will just put their respective values in their respective places. So it would be pq whole squared, pq whole squared. We know the value for pq, so we can put the value directly here, plus p plus q whole squared minus twice of pq plus 1. Now just put the values. Okay. So the value for pq, it is 5 over 2. It is 5 over 2. And the value for p plus q, we got 2. Yeah, we got this in part A, 2, which was 2 here. Okay. So the value for p plus q, it is basically 2. Now just put the values in this fraction. So pq is 2. 2 times 5 over 2. The value for p plus q, it is 2, and pq is 5 over 2. Okay, fine. Plus p plus q. P plus q is just 2. Okay. Divide pq whole squared. So pq is 5 over 2. So 5 over 2 whole squared plus 2 squared minus 2 times pq is 5 over 2 plus 1. Now just simplify it to get the sum of roots. So 2 times 5 over 2, it is basically 5. So 5 plus 2, it is basically 7 over 5 squared. 5 squared over 2 squared, it is 25 over 4. 25 over 4 plus 4. So we got 5 over 2 times 2, it is 7. It is 5 plus 2, it is 7. So 25 over 4 plus 2 squared, it is 4, minus 2 times 5 over 2, it is basically 5, minus 5 plus 1. So in the denominator, you will have 25 over 4. So sum of roots, we will get 4 times 7, it is 28 over 25. Okay, 28 over 25. This is the sum of roots. Now, product of roots. So the product of roots, it is p over p square plus 1, p over p squared plus 1 times q over q squared plus 1. Okay, so in the numerator you will have pq, and in the denominator you will have p squared times q squared, which is pq whole squared. Then p squared times 1, it is just p squared, and then q squared plus q squared plus 1. Just multiply the p squared plus 1 with q squared plus 1. Okay, now same as before, we will get a substitute for p squared plus q squared in terms of p plus q whole squared. Okay, so pq over pq whole squared plus 1 plus p squared plus q squared can be written as p squared plus q squared can be written as 2 plus q whole squared minus 2pq. Okay, p plus q whole squared, p plus q whole squared minus twice of pq. Okay, now just put the values. Pq is 5 over 2. Okay, pq is 5 over 2. Divide, we have p squared q squared, so pq whole squared, this is 5 over 2 whole squared, 5 over 2 whole squared, and then plus 1 plus 1 plus p plus q whole squared, which is 2 squared negative 2 times 5 over 2, 2 squared minus 2 squared minus 2 times. Okay, 2 squared minus 2 times, this is 2 squared minus 2 times 5 over 2, minus 2 times 5 over 2 exactly. Now just calculate the value. So 5 over 2 in the numerator, and in the denominator it is 25 over 4 plus 1 plus 4 minus 5. So this is 25 over 4. So 5 over 2, 5 over 2 divide 25 over 4. That would give you 2 over 5. This is the product of roots. So the equation would be, equation is x squared, and then the negative of the sum of roots. The negative, because let me show you the format. The negative of the sum of roots will be the coefficient of x. So negative of sum of roots, it is 28 over 25. So negative 28 over 25, 28 over 25 x, and the constant, that would be plus 2 over 5, the product of roots. Okay, so we have to represent it in the form of ax squared plus bx plus c. So multiply both sides by 25, you will get 25x squared negative 28x plus 25 over 5, it is 5. 5 times 2, it is 10, equals to 0. So a is 25, b is negative of 28, and c is 10 here. Okay, so this is the equation we found that has roots P over P square plus 1 and Q over Q square plus 1. And that's the answer for part B. Fine.